Hi guys, welcome back to my channel. In this video, what we are going to see is how to pre-process and load audio data to model the machine learning model. Okay. In previous videos, what we saw was um, we see in how to pre-process CSV files and images and what video. The last video I more struggled to learn video because that's the first time I learn about how to produce a video. And the thing is, this isn't a tutorial channel. I'm documenting how I'm learning. In tutorial channels, they often go through trial and errors and trial and error before getting the code. Okay. Then they show how they show their final results. But I am showing how my learning process, which may be different, maybe even bit boring also, but hopefully it's useful because the thing is we need to know how to learn the things, otherwise we can't learn new things. That's the third plan. Okay, we will. In previous videos I used Colab, Google Colab. In that they have create for tensor GPU. That's, I think, per day they have only 1.5 hours. That's not enough. So now I'm using Kaggle's right. Kaggle's GPU. They have wait a minute. Okay, I will show. They have pretty like this one. We have per week they have 30 hours. I think the week is started yesterday. Yesterday is today. I think it's today. Sunday is starting day of the week. So today I used 24 minutes, and they have the GPUs also. Tensor T4 is the fastest one, others little bit slow. If we load a large model, that's if I use GPU, it get more times. I model some what OCR. In that it takes more time, so I use this one and I will complete almost an hour to complete 10 epoch. But in using T4, it like something, I think, 10 to 15 minutes to complete 10 epochs like that. Okay, we will go through this simple audio recognition. After this, I think I will use Kaggle because it's convenient for me. Okay, I want to image my video. Okay, recently many people are subscribing my channel. Thanks. Thanks a lot. Okay, we will start from here. Simple audio recognition, recognizing keywords. This tutorial demonstrates how to pre-process audio file in the WAV format and build and train a basic automatic speech recognition ASR model for recognizing 10 different words. You will use a portion of speech commands dataset which contains short 1 second or less audio clips of commands such as down, go, left, no, right, stop, up, and yes. They have, okay, I will run it. They have data set. In that they have subfolders, uh, each class like this, and they have under this down folder they have many of the audio sounds, that's wave sounds which are in some may not get someone speaking as down, go, left, like that. We will see that In Kaggle, here we can input a Kaggle file. We can directly come here, but uh, while I died, sorry, while I downloading using GitHub or somewhere, this one is from your Google Tensor. Okay, uh, TensorFlow already they have some data set. I think this one also data set. So it will come here as output file, and this one is accelerator. They have we can select this one the Python. They have R also. We can use R. This one is a persistence. I'm not going to use those things. Okay, that's not here. Okay, we can see after downloading the data set, we can see it will appear here. I will show. Okay, first we want to set up the libraries. Import necessary modules and dependents. You will be using Terra's TF Keras utils audio data set from directory in I think before yes, in that we use from directory now to select the different classes. In here we are using audio dataset from directory. Okay, we will check. Yeah, we want to. It's here what we use. Yes, to load the image we use tfkeras util image dataset from directory from to load the image files. Um, for audio files, it will it like audio dataset. I think for CSV or something. See, okay, here text classification. This one is pre-trained model. No? Yeah, that one is pre-trained model. If we go to my GitHub profile, they have a TensorFlow study, and there they have these all files. If you visit, don't forget to follow my GitHub profile also. Then you can get instantly after I am updating codes. Okay, here we use TF dataset. No, that one is different. Dataset text dataset from directory for text one. Like that, we can use according to our need. For road image, I think they have two. This one is dataset, not Keras. Keras one is different. We will see that one. There is Keras. This one, yes, this one is looking at subset folders. No, no, I forgot that one. Okay, like that we can get things. Yeah, so here we are using Keras utilities. That one is audio dataset from directory introduced in TensorFlow 2.10. Okay, which help generate audio classification dataset from directories of WAV files. Okay, that's the thing. You will also need Seaborn for visualization tutorials. Tutorial. Okay. Okay. What's the first one is pip install upgrade. What's mean we don't know. Here we are installing TensorFlow and TensorFlow datasets. Okay. After that, if I don't know something, I want here. We don't need here. They have no AI tools, so I think we will use ChatGPT or Gemini or whatever. We will see. Import OS. Okay, we can use What I forgotten that. So perplexity is something they have. 70B perplexity. We perplexity labs. We can use 70B something they have. 70. I think they. Yeah, man. They have already pre-trained model for coding. No, it's not. Okay, but we will see. We will see what. Okay, import OS. Here we are importing OS library, path lib, that one, met.lib plot, that one also we shown in previous video. I have a separate video for met.lib. Yeah, for met.lib, they have a separate video, which means met.lib library is for visualizing things, numpy for array array addition, like that array mathematical thing. Seaborn for visualization, TensorFlow is the machine learning algorithm. Okay, here we are importing layers and models. IPython display. What's IPython? What it's like? I have no idea. Set the seed value to experiment reproducibility seed 42. If we set seed, which means we get randoms, but those randoms are exactly equal in when we mm, run the code different times. Which means if we use different values, it will give random same different random like that. Okay, I think they run the code, so they have all things. We can see the data set view. Yeah, me. Right. Okay. This is the data set data in here. Okay, so to save, import the mini speech command dataset. Okay, now we are going to import the dataset. To save time with data loading, you will be working with smaller version of speech command dataset. The original dataset consists of over 5,000 audio files in audio format of people saying 35 different words. This data was collected by Google and released under CC by license. Okay. Download and extract the mini speech command zip file containing the small speech command dataset with okay get here keras util get files. Using this we can download dataset from libraries. These are we saw those things in our test video also. Yeah, somewhat like it. Okay, editing here. Okay, what we are doing here? Here we are specifying the path. Okay, it's data mini speech commands. Mini speech command that is what it will going to download. Okay, if not data will exist. Okay, not it will create the one. Okay, it will download the okay. Here what's happening is we are downloading the zip file and we are extracting to the directory. That's what is here. We can see here they have different folders. If we go to the up, they have many audio files. That's someone speaking up like that. They have many things. If we think it's almost something 1,000 or something, you can see later in the how many audio files in them. Okay, we're gonna go to okay. The dataset audio clips are stored in 8 folders corresponding to the each speech commands like that and stop. Okay, commands. Here we are putting those command to numpy. Okay. Yes. TF input output G file list directory. Okay, they have no things now. This one is involves str data directory here. This one. Okay, what you are doing here? We are extracting each of the comma words here in these folders. Divide into directories. This way, you can easily load the data using Keras utility audio from directory. The audio clips are 1 second or less at 60 kilohertz. The output sequence length 16,000 pairs. The short ones to exactly 1 second and would trim longer ones so that they can be easily fetched. Okay, I want to see what's this one, what's happening in here. Okay, that's what I say. Okay, now what we are doing in here, we are splitting uh, training set and validation sets. Mm, in the mm, other sets, we split different. We split each. Yeah, we see. These things we split. Not this one. Okay, I will say this. Sorry about struggles. Train data set validation. We are splitting okay, we are splitting training data set and validation data sets. Data under this directory. Batch size as 64. We know what's batch size, which means it divided 64 and dividing like that. Validation split for validation 0.2, which means 20 percentage. For training 80 percentage. Okay, CD is 0. Okay, output sequence length. Okay, they have in previous also 16 kilohertz, which means 6,000 heads, subset both. Okay, now here we are putting the values. Found 8,000 files belong to 8 classes. Using 64 files for training. Using 1600 files for validation. Okay, they have um, this. They have these labels. Okay, the data set now contains bases of audio clips and what in integer labels. The sound clips have a shape of batch sample channels. Training dataset element specification. In previous things, we used dot shape. If we fold, then they will give how the shape. In here, we are using element spec. Okay, they have 16,000 data type TensorFlow 432. This function is returning as array. Chemically. Shall we check that? Okay. Right. If we have about something, we can go like this one. We can visit the documentation and then we can read like this what we if we call this function what it's written like that. Let me see like yeah even if your directory structure in our structure directory structure should like this one. Okay, we have like this. Okay, that's one is fine. Okay, audio set main directly label included and will return a will patches of audio files from subdirectory class A and class B together label 0 and corresponding to class A and 1 corresponding to class B. Okay, like that it returns. Here we can see what's it's returning. If label mode is int, the labels are int32 tensor of shape, mesh. Okay, the label. Okay, from here I want to. If from here I want to read a TF data set object. Of that we are using for generate a TF data set from audio file directory. That's one thing. Then call okay, that means directory we want specifically we are labels. We want to use what are the labels in here? We have this okay label. We are not using label because we are splitting label mode task name. But we are using seed. We are using seed. PC option random seed shuffle and transformation. Subset. What is subset? Subset of the data to return. One of the training and validation or both only use if validation it is set. Okay, here what we are doing is we can split training and mm, training and validation. Here we are splitting to two training and validation in both. That's why we are specifying they are both. Okay, verbs. We are not using verbs. If the label mode is known, it's a string tensor of shape, text size contain the contents of the batch of the audio files. Otherwise, it will need double audio labels where audio has a shape, batch size. Okay, here what's happening is it will return the audio in the label, audio in the label. Non 60,000 non. This dataset only contains single channel audio, so use the TF's use function to drop the extra axis. Okay, TF's use for um, function to drop the extra axes. Okay, okay, here we are creating a use function. The arguments are audio and label. Okay, we call this one. It will use the extra axis and return the audio and label. Okay, to use the training dataset and validation dataset, we are calling here. Okay, the util audio dataset from the library function only returns up to 2 split. It's a good idea to keep a test set separate from your validation set. Ideally, you did keep it a separate directory, but in this case you can use dataset as hard to split the validation set into two halves. Note that iterating over any shared will load all the data and only keep the fraction. Okay, what we are doing here, okay, to split the validation into two halves. Note that iteration over any shared will load all the data and only keep its fraction. Here we are what we are doing here. We are to split the validation set into two halves. No, okay. Hmm. Ideally, you'd keep it separate directly, but in this case, you can. Okay, we don't know how to um, split into put into two directories. Here we are calling the shared and dataset.shared, and I think that's how we are maintaining that. Okay, so training dataset. This one number of shared. I don't. What's okay? We will go through other things. For example, audio example in training data set. I don't have idea how. Ah, okay, okay. Training, okay, they have two variables. What is one is audio, another thing is label. In training data set, take 1 minute. Oh, I think let's take one. Take one. I think let's change this. Take one. Let's check. Want to do this. Better to go ChatGPT. Okay, we will go to ChatGPT. ChatGPT. Yeah. ChatGPT. Okay. Go to ChatGPT. Okay. I previously studied here, so this one is Chat. Will put it here. The code snippet you provide is typically used for inspect the shape of the data in the TensorFlow. This data might be used for training and models such as audio. Okay, those things I know. No. Okay, so right. I need to know what is take one. This command take one batch of data from the dataset. Okay, okay. We split it using 64 batches. So if we using dot take one, it will take the one batch, which means 64. In our case, 64. Yeah, showing um, okay. In here, we are taking one batch. We specify here we are main, we are west, we are seed 64 batch size. We put it out. Here we can see that our batch size is 64. For if we take the first batch, they have 64, 64 audio files. So it's 64 audios and 64 labels. We are in this we have okay, 64 audio files. Each of that 16 kilohertz. So that's what 60.16,000. The batches are 64. Okay, let's plot the few audio waveforms. Label names. Okay, here 1130, 14 go, 34 no, 04 down. Okay, after that, using matplotlib, we are plotting the graphs. Okay, here rows, 3 rows, 3 columns. Okay, n is row into column for I in range n. Okay, each of these. And what we are going to plot is plot, subplot, rows, columns, e plus 1. That's fine. Rows, columns, I pen. Okay, audio signal. Okay. Yeah, audio signal, sample audio, I. How we are calling this one sample audio? I think they have sample audio or something called sample audio. When they must not like that. How is it like that? Get someone. Sorry about these things. Because sometimes I'm pleased and thinking like that. So we will see what. Here how it's calling audio signal. Okay, that's one is wrong. Sample audio to test stereo. Where we get a sample audio? Example audio. Okay. Okay, got it. Getting example audio. Example batches from training dataset. First batch. Okay. So here, what you are doing is we are printing those labels those audios waveform. Okay, audio signal, sample audio, I then it will iterate to each and here we can see this one is first go waveform is like that one, and this go waveform is like this one. A huge difference, no? I don't know how they pronounce. Okay, and after that, plotting the audio signal and label, same as the label. In here, we are taking audio and example label. So we can specify the label here y-axis and other things. Okay, how like that we are plotting. After that, convert waveform to spectrograms. Okay, we are now this one is waveform. Spectrogram means this one is a spectrogram. Okay, the waveform in the data set are represented in the time domain. Next, we will transform the waveform from the time domain signal into the time frequency domains signal by computing the short time Fourier transform to convert the waveform to spectrogram. In engineering, we studied Fourier transform, how this wave we can transform into, here we are using time series. After that, we are in here, I think, in the frequency series. The basic things we are studying in engineering mathematics. However, after seeing somehow it's applied in these things, it's like some pleasure. It gives some pleasure because I think when we studying, why we always thinking why we are studying like that. Okay, to convert spectrogram, which shows frequency over the time and can be represented as 2D image. You will feed the spectrogram image in your neural network to train the model. Okay, Fourier transform TF signal TTD also FFT convert a signal to its component frequencies but lossless time or time information. In comparison, STFT TF TensorFlow signal STFT split the signal into window of time and run a Fourier transform on each window, preserving some time information and retaining a 2D tensor that you can run standard convolution on. Okay, create a utility function for converting waveform to spectrogram. Okay, now here we are creating a function to convert waveform to spectrogram. The waveform need to be the same length so that when you convert them to spectrogram, the results have similar dimension. This can be done by simply zero padding the audio clips that are shorter than 1 second using TF zeros. When calling TF signal STFT, choose the frame length and frame step parameters such that the generated spectrogram image is almost square. For more information on the STFT parameter, choose the refer this Coursera video on audio signal processing and STFT. The STFT produce an array for complex numbers representing magnitude and phase. However, in the tutorial, we will use the magnitude which can deliver by applying TF ABS. Okay, okay, guys. These tutorials are basic, like hello world. So here we are getting the four things, begin things, how we want to process and load the thing. Uh, I think they have some advanced tutorials in the TensorFlow also. Here we can see. um, Here we can see. Okay, in here we can see. In advance they have audio. In that they have a generator music with the RNN. Those I think those are more fun than these things. We will see those things upcoming videos. Now my basic idea is first, I want to complete this beginner tutorials. In previous videos we complete those things, and now in here we completed images. So images we completed, video also completed with more struggle. CSV, NumPy, those things. We already used TF record, additional format with sense of I don't know about what's under this one. Text. They have more things. Unicode mean that, yeah, how I can say, for emojis we are using Unicode. That subword organizer, we will see. We can't study these all things in one video, guys. We want to study continuously, then only um, we can achieve some place, because they have many things. I want to post each videos containing some information, which means some main things, which mean in this video we are saying how to pre-process and load the images like that. I yeah I study something OCR also, but I didn't make the videos for those things. I think upcoming videos we will see OCR and image captioning like that. Okay, we will see this. My English is something, some, but not fluent. My English is not fluency, so sometimes I struggle to speak. Um, I don't want to write all the script and record. So I speak as who am I. Uh, so if they have some wrong things, please give your feedback. Then I can improve those things. I'm also try to improve how I want to speak more clearly and more specifically. Okay, okay, we will see. Okay, the STF produce an array of complex numbers representing magnitude and phase. However, this tutorial you will use the magnitude, which you can deliver by applying TF ABS on the output of TF signal TFT. Okay, get spectrogram. Here we want to input argument waveform spectrogram TF signal as a okay waveform, frame length 255, frame step 1 to 8. Okay, that's what here we see. We want to, okay, then step, they have two step. Yes, two step. Obtain the magnitude of STF. Okay, that's what he saying. The STF produces an array of complex numbers representing magnitude, and however this tutorial you will use the magnitude, which you can derive by, okay, using this one we are um, getting the magnitude of spectrogram at the channel's dimension, so that the spectrogram can be used as an image like input the data with convolution layer, which as expect shape, match size, height with channels. Spectrogram TF new axis return spectrogram. Okay, if we call this function, it will return a spectrogram. Next, start exploring the data, print the shape of the example, tensorize waveform and the corresponding spectrogram, and play the original audio. Okay, okay. And the main thing is what we are when we modeling a model, when we yes we want to pre-process the data, we are going to shape the array shape. That's what the main thing, and we want to input the shape as exactly same, and we want to process that shape. Yes, that array. In our previous video, if you see how the neural network work, we can, so in that video, how the metrics work, and the from a matrix to how then layers work. the connection between that matrix and layers. So that should be same layer and matrix things. Here we can see that okay, in here what we are doing just a for loop and going to that batch file we already taken. No, here for iterating through those things. This one they have a 64. In here we are just getting a 3. From there we are getting the label in waveform and spectrogram. Calling that get spectrogram. Okay, we are printing the label, waveform, and spectrogram shape audio file. Here we can see that waveform shape is 16,000, which means there are 16,000 kilohertz we specified previously, that one. And the spectrogram shape we can see this is the shape here what we are going to input. Um,
Go, go, go,
okay, this is the first video. Is it audible to you?
go,
I think it's not.
go.
I have noise. No,
No.
this one is play. Okay,
left,
here
left,
we see the shapes. Those are all are exact shape. Okay, now define a function to display spectrogram. What this one is converting a spectrogram function. Here what we are doing is plotting spectrogram. Okay, here what we want are the arguments spectrogram and x is if a length spectrogram shape greater than 2 set length spectrogram shape equal 3 spectrogram skews. Okay, the convert the frequency to log scale and transpose so that the time is represented on the x-axis columns. Add the epsilon to avoid the taking along of 0. Okay, what am I doing here? Long spec height, long spec program. T. Isn't it show the functions? I think that I don't know what's a T. Okay, let's see what's T. Yeah, we'll go to chat engines. And this code usually prefer to taking a transpose of a spectrogram matrix. Okay, T for transpose. NP file info. Okay, floor. ESP. What's mean by ESP? Transpose plus. Hmm, excuse me. Yeah. In Python, it's very positive number that represents the small difference between two distinctive 4-point numbers. Machine epsilon. Okay, epsilon. 4 years before epsilon. Okay. I what we are doing. Okay, we are adding those things using a log function. Okay, okay. Somehow we are getting plotting the factor and if we go through how it's going, it will take more times. Already I think I passed the hour. We'll see how much time I am recording. Yeah. No, 44 minutes. The videos are such a big and otherwise I can't get what's the idea behind these things. Plot the exams away from over time and corresponding spectrogram frequency over the time. Okay, what we are doing here, again we are plotting this time scale waveform numpy okay, title waveform okay 0 to 15,000. Okay, just we are plotting the waveform, also spectrogram, calling that we have substrate spectrogram, not here, not here. It's plot spectrogram. So talking times okay, here we are calling function plots spectrogram and spectrogram number equals axis 1. Okay, here we have converted waveform to spectrogram, which means waveform is using time series. Is it? Yes, using time. Am I correct? Okay. Time domain signal into time frequency domain. Okay, time frequency into time frequency domain. Okay. We are converting time frequency domain. Here we can see there was small. We are also doing. Okay, what we are doing is now create a spectrum data set for an audio data set. Okay, using this one, we are getting a spectrogram data set. Okay, just make a spectator dot map. Okay, tf dot data algorithm for caching. Okay, here we are getting three things: time spectrogram data, validation spectrogram data, test spectrogram data, lambda function, audio label, get spectrogram audio label. Okay, those things. Examine the spectrogram for different example of data. For example, spectrogram examples in time spectrogram take. Here also we are getting a fetch file as this. Here we are getting these two things, especially in the spectrogram data things. Okay, here again we are plotting. So we are specifying the whole image, and after that we are iterating through each one, and we are creating a for loop, and we are plotting each image using this for loop. Okay, okay, build and train the model. Now we pre-process. First we load the audio files. After that we pre-process. Now we want to build and train the model. Okay, add dataset cache and data operate reducer load latency while training the model. This one also we studied in the previous videos. We are using cache or prefix using auto tune. It will automatically capture how much we want to cache. Buffer size. Yes, that one is buffer size. For the model, you will use simple convolution neural networks since you have transformed the audio files into spectrogram images. Here, TF-Keras sequential model will use the following Keras preprocessing line. TF-Keras is need to downsample the input enable the model to train faster. Okay, normalization. We saw these things in our previous video. Normalize each pixel in the image based on the mean standard deviation. Okay, the following normalization layer, its detect method would first need to be called on the training data in order to compute aggregate statics, that is the mean and the standard deviation. Okay, what we are doing here, input shape, example, spectrogram shape. Okay, input shape, number, what? Num labels. Okay, normalizing layer, institute layer normalization. Fit the state of the layer to the spectrogram with the normalization elect. Okay, here we are using input Best as input layer here we are calling that spectrogram shapes. Okay. Using downshaping those images. Can you do anything to do? Okay. Coming from what's this? Okay. Convert the number to string to an integer or return 0 if no argument given. The number return for let's say into number of con of flatten for 42. Okay, input shape we can see the input shape this one. After that we are changing the shape resizing. Okay, using conversion 2D like this one. After flatten we can see that the layer is becoming a single layer. After that they have a dense layer dropout, which means it will drop out here what in after this one this layer it will drop out the 25 percentage of the data after this one 50% of the data, and final it will this one is output layer will give uh, audio file belong to which class. Okay. Configure the Keras model with the Adam optimizer and cross entropy loss. Using this one, we can use how much accuracy and loss in train and model over 10 epochs for demonstration purpose. Okay, if we find more epochs, it will. Why my video is. What happened to my video? Okay, check. If we increase the size of the epoch, the accuracy level is increased. Okay, we can see those things. Okay, here we are plotting the accuracy and loss. We can see that when we sorry, when we increase the epoch, we can see that the accuracy level is increasing and the loss level is also decreasing. In here we can see that the gradient is higher than in here, which means it will the accurate increasing percent also decreasing in here. Here the loss also decreasing, gradient is decreasing like that. Okay, now we will the model performance. Okay, in previous things we will specify what are the thing we want to loss function and those things. Loss function this one. Okay, in here we can model.evaluate. We can use how our accuracy and loss thing. In here accuracy is 0.83 is nice. Losses I think it's a bit high, 0.47. No, it's been almost 5% like that. No, displays a confusion metrics. Okay, I will show that. Use the confusion metric, check how well the model did classify each of the command. Okay, in the machine learning thing most of the things are the first thing we want to do, load the data. That one is the big step. After that we want to pre-process the data. That another big step. For modeling, that one is a part not that that much complex. After that we want to uh, visualize the things, how worked, how much the accuracy and those things. Those are the things you want to know. So most of the things we are, if we know how to work with data properly, we can um, train well. Okay, these are just plotting, so I'm not going to okay, I will see why. If we y prediction model predict our model is okay, model's name is model in yes. In here we can see history model history. Okay, model predict test spectrogram data. Okay. Just I will see. Here we can see these are the testing data. Y2, Y prediction, confusion matrix, validation, testing, confusion matrix, prediction, testing data. In here we can see when the actual thing is down, um, our prediction is two times yes and one times right, which means it predict down as a right and two times as a no, seven times as a go. In the most of the time, 82 times, I'm predicting down as a down. So if we see this diagonal, we can see most of the time it's back right. I think we can see go as a no because the we can see the go no the same sound, so it will predict as same thing. Okay, run the interface on the audio file. Run inference on audio file. Finally, verify the model prediction output using the audio input audio file if someone else know how well does your model perform. Okay, now we are doing is um, we are importing else uh, co- uh, someone else recordings as no, and we are predicting to which class it belongs. Okay, here we are getting data. Okay, using this one as mm, as previous one, we are pre-processing things, and using model.x we are predicting the label. We can also put our voice also here. I want to record for those things, record and upload it here. Am I directly uploaded to here? I want to see. I want to upload it here. Can I upload? Yes, I can upload, but no need. Just really check this one. Okay, now after this one, it will, okay, now it will give the label. Okay, here we can see it predicts no as a go also little bit.
No.
Okay, as the output suggests, your model should have recognized the audio command as no. Okay, that's fine. Explore the model with the preprocessing. Okay, after modeling all the things, we want to export the model. Dot using dot saves and that. The model is not very easy to use if you have to apply those preprocessed steps before passing data to model for inference. So build the end-to-end version. Okay, here export. We are calling the class. We are creating a class export model. Okay, accept either string file or batch file waveforms. Okay, okay. If they pass the test run export model. Okay, after that, what you are doing? Save and reload the model. Then reload model gives the identical output. It's giving, okay, here we are exporting the model so we can use it later. Okay, this one is saved file. We can use only using this one. After model, we can export this those things to this file. So after when we want to reuse this model, we can just code like this one. Yeah. Yes, tf save model saved import. Okay, using import tf save model load save like that we can use it later. Okay, after the next step, this tutorial demonstrates how to carry out simple audio classification automatic saying speech recognition using convolution neural network with a TensorFlow and Python. To learn more, consider following resources. Okay, in upcoming videos, we will see these things. When we study the basic things, we have more unambiguous things. Um, sorry, not unambiguous, ambiguous things. So when we doing the project things, we can play those things. So I think I'm passing my problem. So after when I upload the when I uploading project videos, I think it's more fun than these things. These are more like theory part. So when I posting practical things, it's more fun. Okay, don't forget to subscribe and keep supporting us, guys.